Yes, I thought we may as well have something nice and sunny and a nice background.
Yeah.
Nobody wants to see the back of my house.
Okay, so we should just be going live on.
I think people recognise this.
Is this from today's programming, Philip?
Yeah,
I
so
might be the only one who doesn't recognise that.
Cool. We're now live on YouTube and Twitch. I haven't checked Twitch, but I presume we're live on Twitch.
Is there a way to see how many people are watching via those channels as well? Are you surrounded by monitors and you're like kind of, you know?
One watching now, which is probably me. Yeah, I'll certainly know afterwards if we don't look at it now. I can certainly tell you afterwards. And I think we are. If people do bring up that stream, it'd be good to mute it because it will cause all sorts of havoc. Because as we tested it earlier in the week, it was lagging a little bit, but then the audio plays through, so it gets very, very confusing. So what I'll do now is let's kick off. And so I've got too many screens, you see. Let's do this. What are you doing, Philip? What are you doing? Right, okay. That's not a distraction at all.
Has anybody sent Dan the link? I've just seen him comment on the meetup.
Who's that commenting on Meetup? So if somebody can have a look at that, in the Meetup, if you signed in, you should see the link where the location normally is, if anyone is struggling. So thank you very much, everyone, for joining the first MK.NET virtual Meetup. And yeah, as we've kind of been chatting before we started officially, you know, this is a little bit of an experiment for us because we are doing this for the first time, and we've tried to keep it as simple as possible, but we are live streaming to 2 other platforms at the same time. So, and you know how meetups and technology, and always technology issues, well now, because we're entirely based on technology, we may have, the problems may be more substantial, but we'll see how we get on. So before I start, for those folks who are new or don't normally attend MK.NET, first of all, welcome. I just thought very quickly, just introduce the team. So MK.NET is organized by Layla, Jim, and myself. Layla does most of the work, and Jim and I are just there to look pretty, to be honest. And yeah, so if you want to speak or you're kind of interested in just getting into speaking generally, do give us a shout out. And obviously this new format with every meeting being remote means that it's a bit more accessible, hopefully, to other people who couldn't normally travel, maybe people who couldn't have the time away from family or other commitments in the evenings. And of course, still open to suggestions around doing this at a different time, different formats, different platforms even. So given it's probably the first time some people are using Zoom, I thought I'd show you 2 kind of very, very brief things, just so that people can have a play around with them, which I can see actually most people have found already. One is the kind of virtual background. So if you've got the app installed, I don't believe this works on the virtual app. When you click on the little up arrow next to the camera, you can then choose virtual backgrounds, and then from there you can choose either video or still. If you've got a green screen, it works better, but you don't have to have a green screen. It can still work for you. So there's that. And also wanted to kind of bring your attention to these options around giving non-verbal feedback. So one of the things you'll find obviously on the stream is, for example, if you want to ask a question, it may be hard to to have, for somebody to kind of notice you. I'll share a link on the next slide or so around using Slido for doing Q&A. But also, if you just want to say thanks or thumbs up or whatever, there's this option. If you go to participants, you can essentially just tick one of these options. So just thought I'd mention that as well. And yeah, so what we'll be doing is we're using Slido for Q&A. So if you've got any questions for Cliff, especially if you're on one of the streaming platforms where you're obviously not on a mic, feel free to ping questions on Slido. So just go to slido.com and use the event code MKNet. And yeah, and what I'll try and do is I'll try and keep an eye on those as well. And Cliff has access to that screen, which I don't know if he's had a chance to set up yet.
Yeah, I've got it here. I'm looking.
Excellent.
I'm just making sure I'm virus protected.
Okay. Yeah. You can talk about that when I hand over to you. Yeah,
that's why I keep disappearing off to check the printer because it's printing away at the moment.
Yeah, so Cliff's got a man cave. I think we're all envious of. So I'm really excited to introduce Cliff. I'll let him do a more formal introduction. Cliff's spoken at mk.net. This is his third time now, which I think is a record. So I feel like we should give you some kind of special mug or something, Cliff, but maybe you can 3D print one and send you an STL file or something. Or a little trophy.
Yeah.
So without further ado, I will hand over to Cliff. So I'm going to stop my share. And I'll let Cliff take over.
I need to, there you go. You should be able to see my screen, yeah?
Not yet.
Hold on. That's because I need to do that bit and that bit. There we go. There we go. You should be able to see it now, yeah?
Yes.
No, you still see me, or
no,
you can see it. Oh, okay. Because I can't see what you guys can see. If that makes sense. So, yeah, I remember talking about Handy. What was the first one I talked about then? This is the third.
T-Doda.
Ah, yes, yeah. So, I work for British Airways still at the moment. We'll see how that goes. And I fly the 787 around the world. And so that's why I'm kind of started talking about this sim that we built on Dylan's little Slack channel. What was it, about a week ago, I think, Shahid? And then ended up doing a quick kind of 10-minute talk about it. And then it's turned into people asking for me to make a longer talk about it. And it now turned into a talk that might be good for conferences. So some feedback would be great. It's the first time I've given this talk in this detail. So please do let me know either in the chat or on the Slido thing, which should, there you go. There's the Q&A for Slido. So if you go to slido.com and event code is #MKNet, you'll be able to post questions. Shahid's going to monitor that as well for me and pipe up in case I missed the questions. So any questions over there, it'd be great. Ask as we go along because they may be, in context with what I'm showing and talking about. But that is our simulator that we tow around to air shows, corporate events, schools, for STEM events, etc. And Chris, who's in the chat with the Chris Wave, there you go, helps us massively. His company, Future Software, as you can see the logo there, helps us massively looking after this. We get no support as a small team from British Airways, or very little, shall I say, none financially anyway. So whatever money the sim makes, air shows and events, and especially the corporate events, goes back into the simulator and supporting the various charities that we support. But the sim has not always looked like that. Back in the day, when me and Chris first started looking after this thing, it looked like that, rather dilapidated, as you can see on the left-hand side. On the outside, it was starting to rust and it had moss growing around it. And on the inside, it had a couple of Dell PCs, tower PCs that got damaged when it was driven around. You can see where it was all falling apart inside. It wasn't brilliant. I fly that, which is the flight deck of the 787, and we was just getting these, or just announced we were getting these into British Airways when we started looking at upgrading the sim. And we thought, well, if we're going to start upgrading it, let's stick with something modern instead of this old thing that was loosely based on the 787. So we went with the 787. At the time, we was getting the 380s as well, but one of our managers said that planes don't fly with joysticks; they have control yokes. So she made the decision that we had to have an aircraft that had a control yoke. So therefore, the 787. She didn't realise that the biggest fleet at the time was the Airbus fleet going around Europe, and they all had control yokes or side sticks and joysticks. So we took her in the simulator and showed her that planes do fly with a couple hundred people on board with a joystick, as opposed to a big control column. But there you go. So we took the sim to pieces. You can see was working with quite a few of the apprentices in the engineering team. Completely emptied the trailer. It's, you know, we kind of, you know, like to call it, it's our burger van. So it's completely empty on the inside, stripped all the wall coverings and started from scratch. And we got a bit of a lucky break that one of our 747s was being scrapped at the time. So we managed to steal some parts from the 747 flight deck. And this is Dennis, one of the engineers, happily taking a grinder to a 747 throttle quadrant at the time, because obviously a 747's got 4 engines and we only needed 2. So he basically cut it in half with a angle grinder. So as you can see here, we've got a short throw classroom projector from NEC, and we've got 5 monitors, and then this is all sheet metal that's been bent into shape, and it's all pretty much 1-to-1 scale to the 787. A few dimensions are a little bit off, certainly around the sides of the flight deck, but otherwise it's all pretty much 1-to-1 scale. The other thing we did as well was we wanted to make sure that in the old sim, if I go back to that picture there, this left-hand seat is where the people sit that are having to go in the simulator. One of the problems we had, one of the events we do each year is for dream flights, where we take young disadvantaged and disabled kids into simulator, and every year they have a 747 that flies to Florida and takes a couple of hundred children that are disabled and terminally ill or recovering from you know cancer, something life-changing has happened to them, and they take them to Florida, to Disneyland, with no parents, no siblings. It's just them, some doctors and nurses to care for them, and a load of British Airways cabin crew and flight crew that are along just to be the carers on the day to look after them. We took the sim in this current guys here along to Dreamflight, and there's a young girl who wanted to have a go. She's wheelchair bound and she couldn't get in the seat, but she really wanted to have a go at flying the sim. Her carers couldn't lift her into the seat because it's quite tight. You can see the head space here, which is why you've got the foam padding up top, stop everyone getting a head injury. It wasn't good. So one of the things we thought about was, when we do move to this, we wanted it to be easily accessible. So we moved through upgrading it, and this is obviously the new look on the outside, on the inside as well. And this left-hand seat now retracts about 2 meters, so nicely socially distanced from the control column, and allows full wheelchair access to flying controls. What we also have is a nice ramp. So the engineers also built a nice ramp, marked 27 left. So it looks like the one where Heathrow. And you can see the seat comes all the way back here, so a wheelchair can go all the way around and up to the flying controls, just like this wee lad up here. And now the children get to have a go at flying the simulator, whether they're wheelchair bound or not. The following year, when we went back to Dream Flights, it made a massive difference to the children having a go at the simulator. You can see it's nice, open, airy, spacious. We've got 3 of the short throw projectors, one doing the front and one doing either side. And we've got an instructor station up here, which I'm going to talk a little bit more later. And then we've got the visuals or the instruments doing the display of the computer graphics as well. So you can see it looks a lot better, and the inside is vastly improved, but it took a lot of work from the team. So as you're going to pause, I see Jim's got a credit in the real simulator. Is a control column still fly-by-wire, much like a joystick? It's a bit of both. It's fly-by-wire, but it does have, Jim, it does have some control cables. They tell us are connected, and they basically control elements of the spoilers and the elevator on the tail of the aircraft. So that if we do lose complete control, electrics and hydraulics, then we can still fly the aircraft, albeit very badly. When we do this in the simulator, you're basically trying to keep the aircraft in the air and going while you deploy the VAT, which is the van main turbine. It's a little propeller that drops out the face of the aircraft, and that will give you electrics and hydraulics. And the way the hydraulics is distributed around the aircraft, it means that you can get back systems, even if you have, unlike the DC-10 at Sioux City, where it cut all the hydraulic lines. That can't happen in modern aircraft anymore because of that incident. Aviation always learns from accidents and incidents in the past. So it means that we can get hydraulics and electrics back to elements of the flight control, so we can still fly the plane. But for 4 or 5 minutes while you're waiting for the VAT to deploy and the propeller to spin up, you are flying with effectively, a spoiler pair on each wing out of the 14 that you have, and also the elevator. So yeah, it's connected, they tell us, but yeah, I'm not 100% certain, to be honest with you. Oh, the video's moving. I didn't realize it was a video. There you go. The simulator gets around. So like I said, our little burger van gets towed around by Barry, our tame racing driver, this young, sprightly lad here. He gets about all over the UK, Ireland, and across Europe. It's also been down to Cannes Film Festival. But it seemed a bit silly to have a bigger map with just one pin. But you can see it gets around all over the place. And as I say, most of the events are the big air shows, so Farnborough, Riyadh, and the kind of big air shows down at Brighton and places like that. But also a lot of STEM events at schools and clubs, girl guides, that sort of thing, where we're doing STEM events, and we're trying to push that out a little bit more over the next couple of years. Obviously, we had big plans for this year, but they've all gone up in smoke. And then the way we pay for that as a team is the takings we take from the air shows, and also if we can get 3 or 4 corporate events through the year, so going to big corporate fun days or going to do a team building exercise day with corporate clients, then that money runs the sim for that year and possibly the next as well, which means that any money we do take from air shows goes directly to charities. So that's how we try to run the sim, to get it right. If we were to go back to British Airways, certainly in the current climate, they would obviously tell us where to go. So we need to make sure that we run this at 0 cost to the company, to keep it going. I'm just watching Philip. He's cycling along quite well there. I'm just kind of taking it nice and slowly pace there for you, Philip. So we've got all this lovely visuals that are in front of us in the simulator, but how do we get that all working? We use quite a few bits of software. We use Prepared 3D up to version 4.3, I think it is now, or 4.4 it may be. That is the base software. So that is the flight simulator software. Now, Prepared is owned by Lockheed Martin. They bought, when Microsoft closed up Microsoft Flight Sim, Prepared bought the code base of Microsoft Flight Sim, and then started building on top of it and improving, areas where it was needed for what they intended to use it for, which is in their simulators. So simulating the Lockheed Martin aircraft. It's now leaps and bounds better than it used to be. I've not had the opportunity to try the new Microsoft Flight Sim. I believe it's online only, because it uses the Azure cloud for most of its grunt work for the visuals. But it's quite impressive what Prepared can do. On top of that, we've got the Orbix visuals, which is basically photorealistic visuals for the whole of the UK. We've got that on top so that when you're flying past, Tower Bridge, it looks like Tower Bridge. When you're going past, the Angel of the North, it looks like the Angel of the North. It is really, really realistic and really good. We've also got some airports installed as well from another company, and they model Heathrow, Gatwick, Manchester exceedingly well, down to the point where actually we could use it for actually teaching people what the airport layout is, because it's that realistic and it gets updated quite often. So that's the flight, the simulation, and the view out the windows. The view of the screens that you see in the simulator, we use an add-on which came out late last year from Quality Wings, 787 add-on. That allows us to model a 787 within the prepared 3D software. And the more I play with it, the more impressed I am. As a 787 pilot, I can go into the FMC here and set it up. And you have to set it up exactly like you do the real aircraft. You have to go in and give it the weights, give it the speeds. Otherwise, it gets upset when you try and take off. So you really do have to set it up correctly. The overhead panel, all the switches, dials, buttons, they all work as they would on a real aircraft. Now, admittedly, a lot of them are in the factory setting as if it's come from the US. So some of the weights are in pounds as opposed to kilos. Be nice if you could change that, but they've put it as a fixed graphic or fixed text, so you can't change it to how an airline would have it modeled for them. But it is seriously impressive bit of software and add-on. And for $80, it's seriously cheap as well. We use wide view and FSUIPC. I'll talk a bit more about FSUIPC in a little bit, but that allows us to control the simulated world from outside the prepared software. And then wide view takes the data packet that FSUIPC uses and sends it across the network. So in the simulator at the moment, we have 4 PCs. That's right, isn't it? Yeah, 4 PCs. Nod, Chris. Yeah, there you go. 4 PCs. So we've got one doing the instruments, a couple doing the visuals, and then one doing the instructor station, which is where we've written some software to run that, which controls the simulated world. So wide view takes the data from FSUIPC and prepared 3D and sends it out across the network, and allows them other computers to pick up that data and then use it to model the view that you're seeing. So if this was a PC that's doing an outside view on one of those projectors, it would have wide view and FSUIPC installed and a version of prepared 3D, and it would model this approach, view out the window, to match what the instruments are doing inside the aircraft, which is on a completely separate PC. And it's all frame synced so that it, there's no juddering or jitter, and it works really well. But you do need to make sure the network is set up correctly, which is where Chris comes into, because he's a bit of a guru at that sort of thing. It's way beyond my abilities messing around with networks. But all the software you see here, so Orbix, Quality Wings, FSUIPC, they're all fairly cheap. They're all less than $100 each. Prepared 3D, I think, is £200 for the license for that major point release. So we got the version 4 point release in the sim at the moment, and we got 3 copies of it. We don't need it on the instructor station because wide view does that for us. So we got 3 copies of that. So all the software is less than £1,000 to run our simulator with all the computers we've got inside. Chris could probably tell you how much the computers cost to put together, because he did that, but they weren't cheap. Some pretty big graphics cards in there, some 1080 graphics cards in there in the machines to run it, but it runs really, really nice. Moving on to Chris will recognise this because he drew it. This is the 3 PCs that were in the sim. We've split the graphics PC into 2 at the moment, just for a bit of testing. But you can see each of them has a PC with Ethernet and power. They go out to the control screens for the instructor station we talk about in a bit. The graphics goes out to a Matrox splitter and splits it to the projectors. That's now 2 computers and splitting its projectors. The instruments one is the main, doing all the instruments in front of you, and that's split out to the different instrument screens. And then there's an amp for the sounds, and then all the inputs for all the flat controls, the rudders, the part brake, etc., all go into the instrument suite. So that is doing a lot of work, and that's kind of the most powerful PC in the rack. We're trying to offload some of that load from that PC to give it, so we can up the frame rates, etc. So some of these inputs, we're looking at ways of taking those out and putting them to things like Raspberry Pis, and then feeding the data back into the model using WideView. That's, you know, they're ideas on a bit of paper at the moment, but they're the things we're looking at. Don't know why I've got it growing, but there you go. So the control yoke, unlike the 787, which is fly-by-wire, we've got controls that are stolen out of the 767. Actually, no, it wasn't. It was a back 111, actually. These are out of, so these are seriously old, out of an old back 111 sim when BA retired it just shortly after I joined the airline back in 2005, I think it was, yeah. And so when they got rid of the sim, we managed to steal the control yokes. You can see there, if you roll left and right, that chain there, either side moves up and down, and it moves this motor with an encoder on the ends. And if you pitch back and forward, this long bar across the center pitches and rotates around these pillar bearings here, and then feeds up via this arm here through a gearbox into a motor with an encoder on the ends. So we can apply force feedback using the motors. So as you're heaving the aircraft around the sky, the force feedback system will put a bit of energy onto the motors, not a lot, but just enough so you can feel it. And then the encoder we use to feed the system information, how much you've rolled, banked, or yawed the aircraft, to feed that back into the simulated world. So this all goes via a simulated system that we purchased from a company called BFF Simulation. And it's a really, really clever system, works really well. Takes some setting up. It's not the easiest thing to set up, but now that it's running, it works really, really well. You can see here, these yellow cables are the original aircraft cables that come down the control column, and they feed us the trim switches, the autopilot on-off switch, and the push-to-talk switches that are on the control yoke at the very top. So we've wired them in as well. You can see there's another socket just like that that's dangling down the back. You can see some of them there, actually. And we've wired them into simulated world as well, so we can take control of the autopilot and such. The way we've wired those in, these cables, is we use boards from a company called Leo Bodnar. They make parts for Formula 1 teams and rally teams for race driving simulators. And they produce this board, and this board is basically, you've got all the buttons. This is their keyboard board. And you plug it in, it appears just like a joystick with 32 inputs. So you then go into your prepared 3D simulated world, and you can set up those buttons to do whatever you need them to do. So turn the autopilot on, off, maybe putting the flaps out, and you can select the flap levers here. Maybe it's left engine on, off, right engine on, off. You know, the part brake, that sort of thing would be what we'd feed into this board. We've not used all the inputs yet because we're slowly adding. You can see this is like a screen printed representation of the real aircraft, and we're slowly adding 3D parts that we're building up as we go along, and then adding them to simulate work. Normally we do the work over the winter, and then during the summer it has a summer busy period, and we try not to do any work and make a bunch of money, and then we keep a little bit of that back to put back into the simulator, and we give a big fat check to the various charities as we support each year. And that is a team decision at the end of the year. How much do we keep back? And we always try and keep back as little as possible, so we can give more to the charity. But it means that we do less work on the sim. But you know, it's swings and roundabouts. This is the center console. This is the only picture I had of the center console that showed the throttle quadrant in the center, without everything else around it. So you can see it was taken out while I was doing some work on the other parts. So I talked about back here, how all this connected together, and about how WideView and FSUIPC work. So FSUIPC is the flight sim universal inter-process communications, I think it stands for. I think, I'm pretty certain. Chris is nodding, so yeah, it must be. And it basically means that you can have two processes and they share the memory. So process one would be prepared 3D. Process two would be 787 instructors operating station, not iOS as in Apple. This actually works. There's no bits missing from this one. You can tell I'm an Apple fan. And for a mobile dev. So what they do is they share memory space. And what Pete Dawson and some people before him as well works out is that Microsoft Flight Sim back in the day, and now prepared as it's moved on, have kept this memory space the same. Is they had 65,000 bytes reserved in memory, and within that memory space is all the parts that make up the model of the aircraft. So, you know, airspeed, is the part brake on, etc., etc. And it all goes into that memory space. And the reason it's that size is because back then when Flight Sim started, it was all 16-bit. So it was a 16-bit or a 2-byte pointer. It's off the side of the screen now, actually. I need to make a note of that and fix my slides for the next talk. So the 16 bits of that shared memory has to hold everything. Now, Prepared 3D and Flight Sim in its later days, but now Prepared 3D, you could be driving around in a tank. You could be, you know, moving in a submarine. You could be flying Concorde. So they have to model every bit of data that you'd need for all those different vehicles within that shared memory space. So they've squeezed quite a bit in. So there's a lot of like bit stuffing into data, but there's also a lot wasted, which they kind of hopefully they're going to fix over you know the time going forward. But if we take just a sample of the documentation that Pete Dawson puts out about the offsets. So if we start with offset 0, so this shared memory space of 65,000 bits starts at a location, and you don't know where that is in memory. You just say, I want to modify offset 0, and it will be the first offset, or to modify, and this is a hex value 012C, and it will be the name of the current logbook. So these are the tables. Now this document goes on and on and on, as you can imagine, with 65,000 points. But if we take a closer look at something that kind of we might want to play with, which is maybe the autopilot, because we've got a control panel at the top that I'm working on at the moment that allows us to set the autopilot on, off, allows us to change the heading that the autopilot will follow, allows us to push a button to do autopilot hold or altitude hold. You can see the hex values for the memory locations, that these are the offsets from 00. And you can see the byte size that we're playing with. So, you know, to autopilot heading lock is 4 bytes, and it's at that location. But that heading lock is a push button on the real aircrafts of a 787. So it's Boolean, but they're using 4 bytes. So you kind of wonder what else is going on in that memory space. Heading value, which is obviously, you know, 0 to 360, no matter what, whether you're driving a tank or a submarine or an aircraft. And they put that into 2 bytes. But again, it's 0 to 360. Even if you used to kind of, you know, you can't do decimal degrees in there, because I've tried and it won't let you. It will go to the nearest degree, even if you put in a value which is a half degree. So again, they could probably kind of reduce these down. And the same for the altitude lock is a push button, that's Boolean. But these bytes are where Pete Dawson's worked out that setting a value to non-zero in those 4 bytes puts on the heading lock. Microsoft never sadly published the details of this memory space. It is literally, you can see here the state of SimC. These are new locations that people have worked out that there's 1 byte, the ELAC switch is 1 byte there, and it's been checked, but they're still waiting for more people to confirm. This is the version 5 of FSUIPC. So you can see that people around the world are still checking to see if these bits map correctly to the models that people are flying. And this is it's been around since the kind of late 90s, early 2000s. So it's been around for a very, very long time. So yeah, how you doing there, Phil? You're holding up. Just want to make sure that you're doing well, mate. You're not going to fall off on us. Yeah, excellent. So looking back at these bits then, and so we got the four that I've kind of picked out and highlighted there, and I've broken them down using some fun with Excel. And you can see here that autopilot lock is using those 4 bytes, and it's just a Boolean value. And there's also gaps. If you used to look through the data table, there's gaps here. So there's a gap there of 2 bytes between these. Now that, in the table says it's unused, but it might be doing something that we just haven't worked out what it is. So it really does mean that someone's got to go in there and turn every bit on one by one of the 32 bits that are in that space to see what changes in the model. Now it might be something that's unique to, I don't know, Concorde, or unique to an Airbus, or unique to a tank. But so they've got to try every different model and every different bit to see what it changes. A switch that may only be used in that one model. So that's why there's gaps in the data points. The other thing you have to be careful of as well is when you're writing software against this, you need to make sure you don't go outside your data space, because if you do, you could be turning something else on or off, or suddenly changing a value. If you used to that heading lock, accidentally shift it over, you could be changing the autopilot heading when really you just want to put the heading lock on. So you just got to be quite careful at the when you're using these offsets, that you use the correct offset and make sure it doesn't affect any of the other points. So it then starts to become very difficult, or not difficult, but you just got to think about what you're doing. So that's all the points, and you can see all the bytes here. So 1 byte, 2 byte, 4 bytes, and there's some there that are 8 as well. So we go into, and I've grabbed this from the docs today. Literally, I wrote these slides today, or most of them anyway. So docs at Microsoft. So if we look through what the integral types are within C#, I've written the software in C#. We're looking at single bits, 8 bits, which is a single byte. So it would be a byte, a U short, or a short for 2 bytes, an int or an unsigned int for 4, and it goes on from there to long. And we're not using a char. We don't use that in this space, but that's one of the ones that are not used. So you're going to use whether it's a short unsigned int, unsigned long, or unsigned long, to get the different data points within that. And it's all basically the integral types from C#. So we're writing an offset in C#. Again, we've taken these two from the tables. So the offset for the gear position is a 4 byte offset, and it holds a value from 0 to 16383. 0 is up and 16383 is down. So again, you could literally kind of put 0 or just set them all to 1, and it will give you the same point, but it's an unsigned integer. So we take that 4 bytes to store a value that will fit easily into there. And again, for the pause control, it's a use short because it's 2 bytes, and the pause control is literally a binary on off. You either set it on or set it off. So it's just 0 and it's paused, and 1 will be, or anything non-zero will be unpaused. So again, if you overlap from another memory or another offset into that pause area, it'll then become non-zero, which means it'll be unpaused. So you could be trying to change something else, but keeping the simulation paused, and suddenly you're unpausing it. Other booleans that are used are back the other way. I think it's the autopilot one. On off is the other way. It's 0 for on. 0 for on and non-zero for off. So that could make for fun and games if you accidentally put a value in there. So that's what it looked like in C#. And taking it from the tables, these are the bits that we get out of the tables. So up and it's 1 for pause, so in 0 to unpause, yeah. they're the values, the C# types that we've taken from the table above. Now I'm using. I wanted to write all this in .NET and use C# because that's what I know I love. And Paul Henty wrote this fantastic library, FSUIPC DLL. It's on NuGet. You can pull it in. You go to his link just there. You can look up the docs as well. But it is fantastic, and it's abstracted away a lot of messing around with these offsets. Simple things like working out what the aircraft is, playing with the weather, playing with the lat long of the aircraft. All these kind of things you would do quite often with a flight simulation have been extracted away, and they're literally just method calls or setting a property. And it's a lot easier. You still need to play with the offsets for the weird one fall that you're playing with, but he's abstracted quite a lot, and he keeps growing these abstracted layers as well. So hopefully I should be able to, if I go to Visual Studio and share that. Did that work? Yeah, I'm getting nods, so it must have worked. If I do this. So these are the offsets that I've had to declare. I've been
just
doing
before
it.
you get into that, there's a couple of questions on Slido. Might be good to cover those.
Okay. Why does we select prepared explain? The reason we selected it was because we tested both actually, myself and Chris, and we found that prepared allowed us to do more of connecting different computers together. And because the Microsoft's, it come from Microsoft Flight Sim, there was more packs and downloads and add-ons that we could get at the time for prepared than we could for explain. And with the previous simulator had the computers that were in it were all using Microsoft Flight Sim, so it just made a bit more sense to stick with what we knew, and actually with the software we could get more parts for. Regard to the data table, can't they figure out what the memory locations are from source code? That's a good question, but sadly Microsoft didn't release the source code, and Lockheed Martin are not going to release it either. It'd be nice if they did, but it literally has been many hours of people poking around with that data table to work out what happens when you poke that bit and prod this by it. So yeah, it'd be lovely if they released it. You would have thought, Microsoft would, but they sold the code to Lockheed Martin, and I suppose only they can decide if they're going to release it or not now. Has using C#.NET to work with unmanaged memory ever caused problems? It always causes problems. Yeah, you just need to be careful, like I've said, with these offsets. There's been occasions where I've dropped the wrong hex code into creating an offset, and then wondered why the whole thing goes haywire. So yeah, you just got to be a little bit careful there. But once you've confirmed that the correct offset is doing the correct thing, then I don't touch these. I leave them alone, and in fact, I should make them read only, so that then I'm not kind of messing with the offsets when I'm writing the rest of the code. Even though it's managed here, what this he's doing in .NET is creating the packet, the edited packet of that 65,000 bytes, and putting that back onto network for the other computers on the network to pick up. So even though this is all in managed code, that data packet is literally just the packet was put back on the network and used by the other computers to modify their world from what we're telling it to do. So it's a kind of bit of both, really, as managed and unmanaged. I'm not sure if that answers your question or not.
Could you bump the font size up a bit more, please?
You want it a bit more, yeah? How's that?
Nice.
Yeah, okay. I should have gone to a white background as well, shouldn't I, in my presenter mode, but I completely forgot. In fact, I'll do it now, if anyone can remember where it is. Am I going to break my computer? There you go, there's dark, there's lights. It's going to work. Hey, there we go. Oh, it's bright.
It burns.
So you can see here, I've just got a static class, and I'm going to put more and more offsets into here. This code that we've had, we had a version that was running on the sim that you see in the pictures earlier. It's been controlling the sim for the last few years. That worked great, but the connection used an SDK that come from Lockheed Martin, and the problem with that is it didn't allow you to control everything. It gave you it was a lot of limits. It also didn't like working across the network. It caused lots of problems. The slightest hiccup in the network, it fell over. So we've moved now to fully using FSU IPC, which meant a complete rewrite of the software. Started it about a year and a half ago, and then realized that we had a version that was working in the sim, and then I probably lost the codes, my fault, and the source codes. I had a very, very early version that kind of sort of worked, but had all the extra bits that we put in, or I put in. I've kind of lost. So I've gone back over the last few days and started putting everything back together. But you can see here we've got flat gear and pulse control positions. The flat position, if I scroll across here, obviously that flat position is just a 0 to 16383 value. And again, this is back to your 16 bits. But it doesn't know which aircraft you're flying. Now on the 787-8 aircraft, they are the flap settings. So you've got 0, 1, 5, 15, 20, 25, and 30. So all you have to do is divide 16383 by the number of flap positions, and you end up with each step being 2730. So what I've done there is just create a step value of this. And the reason for that is if we suddenly change the aircraft model to a -9, there's an extra couple of flap settings. There's a 10, a 17, and 18. The -10, which BA are getting, actually they're built, they're just waiting to be delivered, has the same, so it'd be 10, 17, 18 as well. 10 is an extra takeoff setting, 17 and 18 are kind of, they're takeoff settings, but 18 is used occasionally on approach. If you've got really windy and gusty conditions and you need to slow the aircraft down with the barn doors out the back, but you still want to use the speed brake. If you have flap 20 with speed brake and gear down, you get warnings telling you off that you've got the speed brake deployed when you're in a landing config. So we tend to use flap 18 for that because it's almost flap 20. It's only a few degrees in it, but you can then use the speed brake and slow the aircraft down a bit more. And again, it's when you've got strong tailwinds, you're coming around on base leg, to line up the runway, and you need to slow the aircraft down. Certainly in sporty places, America's anywhere in America, they like to make you fly the approach sporty. Places like San Jose, California, they cut you in amongst all these little puddle jumper aircraft or little biz jets and expect you to behave like them, i.e., fly till you're doing 200 miles until 4 miles from the runway and then slow up. Well, the 787 has got a really slippy wing. It just doesn't do that. So they're the flap settings that are in. So what we do is when we start the software or start it up, we come into our main window and we set up 2 timers. The first timer, if I go into the connection timer, so the main timer here, is looking to make the connection to FSU IPC. It's not there, it's there, sorry. Open the connections to FSU IPC and check whether it can see flight sim the other end, and make that connection between the software that's running and flight sim. If it can, it stops that connection timer, which is set at every second, so it constantly checks that, and then starts the actual interval timer, which is 50 milliseconds, and it sets up the form and sets the airport to Heathrow, EGLL, which is the ICAO for Heathrow. If it doesn't do that, it's got a try-catch block, but it carries on. And the reason it's got a try-catch is if that connection can't be opened, or this FSU IPC connection method here, it throws an error, which, or throws an exception, which is not ideal. So you just have to catch it and, not consume it or use it, just to let it carry on, because you'll get called again a second later. In the second one, what we do is every 50 milliseconds, so 20 times a second, we process all those offsets that have been changed and modified. And what happens is those changes, at the moment, we've only got a few offsets. So these 3 here, those few offsets are then put back onto the network and consumed by the other instances of FSU IPC that are running on the network. So WideView takes care of that for us. So WideView picks them up from the local FSU IPC, shares them with all the others across the network, and allows all those values to be changed and modified. And then coming back the other way, we would get things like the aircraft pitch, bank, roll, et cetera, speed. If a connection error happens in here, then we throw an error and deal with that. And then we've got configure form, which is just saying whether we're connected or not. A bit of closing, and we load a database. Now the database is produced by a tool that Pete Dawson also produced, where you load up your version of Prepared 3D or X-Plane or whatever kind of flight sim you're using, and you'll run this special tool. It then looks at the scenery database, finds all of the runways, and then creates a massive long comma-saturated variable table of all the runways that are within that model. So if you was to add a runway or delete some from your database within your flight sim, then that you need to run that model again. So it creates that and loads it into airport databases. Now, Paul Hennity has taken care of that. It used to be quite gnarly code to go through that database and create a model, and then kind of reason over that. But it's all taken care of. It's been abstracted away for us. So we just load the database in. It's done for us. The model's created in the background for us, and then we just set the airport up. So and then if we go across to locations, we have when we set the airport up, we clear out the checkbox runways. We check that the airport database isn't null, and then we take the airport that's been passed in. It's just a string. It's just the ICAO string, and we get the airports and we load the it's not a checkbox anymore. It's a drop-down list of the runways that are available at the airport. And the idea is that you load up Heathrow and you'll get 27 left, 27 right, 09 left, 09 right. And because the scenery model is quite old, it's still got runway 23 in there as well. So you can use that. And because runway 23, you can only land in the 23 direction. So you come over the big, in Hounslow, there's a big gas installation, those things that go up and down with the gas inside. Don't know what they're called. And on the side of that is big and blue, and on the side of it is a big white arrow that points towards Heathrow, and underneath it says LHR for Heathrow. They always kept it pumped up with gas, so we could see that. If the gas was ever let out there, we wouldn't know where the runway is because it was a visual approach. And at the end of the runway, it always made me giggle when I landed on that, because at the end of the runway is the World Suite. So if you went off the end of the runway, you'd take out the World Suite. I'm sure someone along the line somewhere thought of that, which is why runway 23 is now closed. You could never land in the opposite direction because you'd come over the top of the Royal Suite to land on the runway. So you can only land in the 23 direction. And then we just, this is all normal standard C# code, really poorly written by me. So we've got a couple of buttons on the screen. One that positions the
in no way is that code written 4 hours ago, was it, Cliff? It wasn't written 4 hours ago. Definitely.
No. It was written about an hour and a half ago. It needs a bit of thinking and going over. I got it working just so we can use it today. So you've got a position runway. That button just moves the aircraft to the start point of the runway that's selected in the checkbox. 4 mile final. So it moves the aircraft to 4 nautical miles. And again, move aircraft of approach is a method that Paul's built for us. You just give it where you want to put it, and it puts you at the correct altitudes. So that's my method that's further down here. Set gear position, so we set that to true, and then that gets called as well, and then we set the flap. So we've got that set up for 4 and 8 miles, and then putting it onto approach. We've used the standards of 3 degrees, which is standard slope from the ILS, which is instrument landing system. So most, I'll say major airfields around the world have instrument landing system, which is 2 radio signals that come out the runway. One that goes from the start of the runway and comes up at a slope, and you fly down the slope to the runway. And the other one is one that comes out and is horizontal, and it tells you if you're left of the center line or right of the center line. You can tell how much the spelling mistakes are in here that are just comical. So the standard slope that's used around the world is 3 degrees. Now, if there's terrain or you've got rich people living there, so I'm thinking of London City or New York's JFK 13 right, then that slope is a bit steeper. So London City, it's 5.5 degrees, so quite a steep profile. At JFK 13 right, I think it's 4.5. So we take out the ILS info from the actual runway that we're in use, and take the slope, so we update that value, and then we set the heading, so that's the left and right as well, so we grab that as well from the same runway, and then we set we do a calculation offset by nautical miles to set the new position where we want the aircraft, and then we calculate the height as well, because obviously we want to be the correct height to be on the ILS, and then we set a speed of 160, which is pretty suitable for most approaches. We set a bank angle. Now, if you ever look at an aircraft, sort of a bank angle, a pitch, a big jet aircraft, they never fly level. They always got, even come down their approach, always got the nose slightly high. And it's typically coming down their approach 2.5 degrees. So effectively, at 4 and 8 miles, we've got this set 160 knots, bang on profile, with the aircraft with 0 bank and a pitch at 2.5 degrees. And then what we do is we call the methods that Paul's put together of move aircraft, pass it in all that data. And the last true is to say that you want to move the aircraft that position and keep the simulation paused. So that puts the aircraft in the correct position, allows P3D to reload the scenery if it needs to. It allows the pilot that's sitting in the right-hand seat and the British Airways pilot that goes along to these events to quickly brief the person that's going to attempt to land this Krypton factor style, how they're going to land the aircraft, what they're looking for out the window, what they're looking for at the instruments. And then they'll unpause it using the pause button. Setting the flaps position, this is the offset. So this is one that Paul hasn't brought out. So this shows the offset. So we've taken the flap position, and I've just created very quickly down here, just need num of the flap positions. Where's it gone? There it is. And then I times that enum by the step value that you see earlier, and that gives us a position. And then I set the value. The reason I've got that separated is because I was messing around with this earlier. I needed a breakpoint before it set the value. And then you just set that value on that offset and you forget about it. That process timer that we pointed out earlier, that 50 millisecond process timer, then picks up those offsets. And because it's changed since the last time that it was set, it passes that offset back onto the network. All the others pick that up, and then it will set the flaps to that position. And because the Quality Wing software is so good, it will set it, and then the time delay, which is realistic of the flaps coming out. So it could take, up to a minute for flaps to go from 0 to full flap 30, just as they would in a real aircraft. The gear position, again, it's just a Boolean value. So you set it to full or to 0, set the value, and it will set the gear up or down. You can set, and one of the plans that myself and Chris have got is to have a page with faults and failures on. And one of the things we're thinking of doing is freezing the gear half down, or only the main gear comes down and not the nose gear, so you can see we can land the aircraft with no nose wheel or no left main gear. A bit of fun. If you're doing these corporate events, you want the people to be challenged. Phil, I noticed you've stopped cycling. I haven't stopped talking. So, so that's pretty much it that's in there. So if we run this, and then I bring up and I swap this to here, you should be able to see, I hope, the outside worlds and the 787. Is that correct? Yeah, got lots of nods. I've lost the Slido now because I've run out of screen space. So if there's any questions, do I need to answer those first, or?
No worries, you're good. There's no questions.
Yep. Okay. Cool.
I'll keep an eye on it.
And then if I Where's it gone? There it is. If I just, when my laptop catches up, and what I've got to fly this thing is an Xbox controller, which is not ideal, and that's crashed P3D for some reason. Let me reopen that. I'm not sure what you can see now.
We're seeing you.
You seeing me? Okay,
Yeah.
right. Let me share that. So you should be able to see, this is the software as it loads, while P3D gets back up and running again. It takes a few seconds. Can you see that? Yeah, you should be able to see that, shouldn't you? Yeah. So we got here, this is where we're at the airport. We load the database and it's going to try and move the aircraft, but P3D is not running yet. So you can see I've put lots of error checking in. That's because we're not connected at the top. Where's it gone? So you can see there, now it's connected because P3D is up and running. So it should be able to click load now. And you can see all the runways pop in. So we've got the easterlies, the westerlies, and runway 23. So we want to go to runway 27 left, and that will now change the scenery. We've got takeoff, land 4 mile, land 8 miles. We've got a pause, and we've got a load and save snapshot. And all they do is take the current position and save the
Oh, I think we might have lost Cliff. His screen seems to have frozen.
Yeah,
Yes.
it looks like his laptop. So if I just carry on talking a little bit about that interface while he reboots his Surface Book. Yeah, so this
Chris,
is.
why don't you introduce yourself first? Just so folks know who you are.
I'm Chris. I'm new to C# programming, but that's not to say that I'm new to programming. I started in 1977 writing Fortran to simulate what happens to buildings when firecrackers go off 25 miles away. Where we are today, my company on there is Future Software, so we're a specialist technical software development company. So we sit behind the scenes. We're curly brackets rather than chevrons, and we're C++, Fortran, assembler, and things like this. Yeah, this project is so this project with Cliff and I being the main sort of technical inputs on this. This user interface is a redesign. Yeah, we can hear you now. You're back. I was just talking because you were rebooting your book.
We were expertly filling there.
He's on mute. You're on mute.
Yeah, we were expertly filling. So yeah, you mean.
Okay, back to Cliff.
Can you hear me now?
Yes.
Oh, I can't hear you. That's the problem.
All right. Shall I carry on talking until he can hear us?
Yeah, you go, Chris.
Yeah, so the user interface. So this is based on the real sim panels that you get in the flight sims. And the idea is it's a very easy interface to set up because the sim is designed as a 15-minute experience. It's designed to get children, interested people into the sim to experience what it's actually like as best they can. So it's not designed as a rocking chair and a TV screen where it plays a predefined video. This is 15 minutes of them actually playing with a real simulator and it getting to do something. Are you back on, Cliff? Can you hear us? We can't hear you. Go back to the panel. Let me finish off. If I can't hear you, Cliff, go back to the panel. Just switch back to the panel and I'll finish off talking about it. You can't hear us. So the sim panel is designed for the pilots to select some scenarios. So if you have a kid who just wants to go and take off from London, fly into the Shard, it's very easy just to click on the appropriate button, select the runway, and the child can go off and fill their boots flying whatever they want to do and crashing into the Shard. It also does allow for some of the more serious events when we go to like RIAT, which is the Royal International Air Tattoo, or Farnborough, or some of the more interesting universities and places like this. The sim panel that Cliff's written allows us to select different scenarios. So you can be taking off, do a nice little takeoff, roll at the end of the runway, fly towards London, but then we can simulate different weather conditions. We can have an engine failure, we can have a complex electrical failures, and then the instrumentation in front of you will actually adjust itself to that. And that's based around what happens in the real simulators, which are 15 million a time, whereas this is to give between kids who just want to fly and the aero events, you know, like Farnborough and RIAT, where you have people who are sim enthusiasts and they want to have something which is a bit more engaging, a bit more in depth. You know, they know how to fly a plane, they know how to take off, they know how to bank left or right, but they want to feel you know, what is the stress levels when you suddenly find that you have an electrical failure and you lose your instrumentation and you're coming into land and you've got 500 foot of cloud and you're at 1,000 feet. How do you know where the runway is all of a sudden? So the sim allows us to do that with the programming that Cliff's put together. So
can you hear me now?
Yes. Can you hear us?
Excellent. I can hear you guys as well. I don't know what happened there. My keyboard just died in front of me. And everything bing bonged and everything died. I'm not sure if yeah, I think it was a power problem somewhere along the line. Yeah, it didn't like it at all, so it closed everything on me. Sorry about that. As Shahid said, it's all part of the learning curve.
Do you want to go back and actually just show the P3D responding to the sim panel?
There you go. There's the inside of the flight deck, and it takes a while for it to sort itself out. I'm hitting the keyboard that I've just unplugged. So it should. There you go. It should all come back up now. So I dragged that over there. You should see.
Much like the real 787, Cliff, you have to reboot it now and again, don't you?
You do. Control Delete, and I'm not joking. On the performance, we've got a touch panel down either side by my right knee as being a first officer and the captain's left knee. We've got a touch screen which does all the aircraft's performance for takeoff and landing. That is Windows. A very old version of Windows, and yeah, it's there, but it's used because they know it works, and you know it's doing performance. If it doesn't, if it falls over and doesn't work, we get out a big QRH quick reference handbook, which is a really thick, inch and a quarter thick book, and in there is all the charts and tables, and then we get a pen and pencil out and manually work out the performance of takeoff and landing. We wouldn't do it realistically for takeoff. Realistically, we'd go back to stand and get the thing fixed. There's no way I'm going to take off with data I've worked out on the back of a bit of paper. But for landing, obviously, if you have a major electrical failure, you've got to be able to do it and do it fairly quickly. You have some ballparks in the back of your head that you can use. Things like if the runway is more than 2,500 meters, so 2.5 kilometers, you can land on that. You just put, brakes to full and use full reverse, and you're guaranteed you're going to stop before the end of the runway. Because if you look at the charts, the longest runway you need is about 2,300. So a bit for mum, make sure she's happy. So we all use 2,500 meters as a runway length. If the runway is shorter than that, then you would go. I mean, you go at the charts, we've got time, but if you're struggling with an alien aircraft and you just need to get on the deck as quick as you can, you'd look for a runway that's 2,500 or longer. Or if it's shorter than that, you'd have to get the chart and what do I need to do? What else do I need to do to stop the aircraft? So anyway, I seem to be back up now. You should be able to see it across here, and you should be able to see it's looking for a flight sim still for some reason. Let me restart it. up here. So you can see the flight sim here, outside world. I've pulled these 2 screens up just so it's a little bit easier to fly. And I'm going to put the HUD down. I think it's this side. I think it is. There you go. And we'll pause it again. So on the 787, there's a head-up display. And now that it's connected, it's decided it wants to reload. So here we've got, we load Heathrow, and we're going to go 27 left. And then we can set the takeoff, the 4 mile, 8 mile final. And then we've also got a bit of weather in there. So we can do things like making it rain and make it foggy bottom, or we can clear the weather. And again, these are just
Cliff, we're just seeing we're still seeing the loading screen at the moment, so I think it's just taking to load up.
Oh, you can't see. Ah, right, okay.
Yeah,
I thought
it's on 53%.
Yeah, no, I thought that it'd see the whole screen. So Zoom, actually, I've pulled the screen across on Zoom, and what it's doing, I thought it would. Yeah, okay.
We can see it now.
Yeah, no, it's I thought you could see this screen because I pulled this screen across the top of the 7.8. So you can't just drag a screen across in Zoom. It actually looks at the screens. It's obviously looking at the stack, the screens. So this is obviously loaded, and then in the weather, I've got a couple of buttons, and in the ILS plot, there's just some buttons, but that's going to show the ILS trace, and that will get printed out for the person. You see it's connected there. So if I now go to there, and share that one and put that over here. If I go to weather and set it to foggy bottom, you'll see the fact that it, you know, updates fairly quickly in the background and sets it to foggy. Or I can clear the weather again with a button, and it's clear. I can make it rain, and you'll see the rain clouds will come in. Things like rain and winds, they're progressive. It doesn't suddenly start raining like fog. So it will come towards you and start raining as it happens, but we'll clear that out of the way. And then I can set 4 mile, and it puts you up at 4 miles. And again, it will reload the scenery. It will do that on my laptop because my laptop's not, you know, it's a Surface Book. It's not got the graphics card. It's not got the memory capable of running Visual Studio, a Zoom meeting, PowerPoint, and prepared 3D all at the same time. But in the sim computers, that loading bar doesn't appear. And also we have it set in full screen mode, which if I was to do it now, I'm sure it will cause everything to crash. So you can see there's the runway. You can see the puppies, precision approach path indicators, the lights just to the left of the runway, and the head-up display. And you can see the indicators here. And if I was to unpause it, it would instantly, oh, hold on, try and pitch out. So you can see I'm attempting to fly this thing with an Xbox controller. Not ideal.
Excuses in nice and early, Cliff.
I'm getting them in dead early. So and one thing we have not done is turned off the auto throttle because it's powering up the
pull up.
Yeah, I'm gonna. So yeah, but you can see I'm trying to do the keys and everything else at once here. So it's even doing things. If we pause it there, I'm not sure if you can see it, but it's even the simulation model is so accurate that because we're too fast for flaps 15, you can see that green tick just there on the speed tape. We're too fast. We're above that. It's doing load relief, so it's stopping the flaps and slats coming out. So the model is so accurate in the flight model that it's doing that. I'm going to go back to a safe space, which is back on the runway, before I embarrass myself by crashing an aircraft.
Put it to 09 right.
Streamed around the world. So you can see there, we've got total control of the simulated world using some software we've written in .NET. It's just I started it a while back and thinking of maybe moving it across. I was tinkering and playing with Blazor the other day and thought about moving it across so that it's not an installed program. I thought that'd be kind of fun, but we'll see if that would work. Those lights that I talked about earlier, the puppies, precision approach path indicator, you see those 4 red lights there. What they do is give you a visual indication of where you are on the approach. So 4 red and you're dead, you're too low. 4 white, you're too high. You kind of want it 2 red, 2 white, and that will tell you that you're on the correct path for landing. So if I now go back to, where's it gone? It's over here now. I've moved it somewhere. And go back to the slides. There you go. So that's, I'm hitting the wrong keyboard. That's yeah, that's the software that we've written, or I've written. That's controlling paired 3D all inside a simulator that we show around, like I said earlier, to corporate events, air shows. These are the charities we support. So we support High Flight, which is a flight operations charity, which behind the scenes supports flying scholarships for disabled people, which gives 2 people every year, normally issued at RIAT, Royal International Air Tattoo. We say who's going to get the bursary for next year, and we give 2 disabled people enough money to go and get their private pilot's license. And also High Flight takes disabled and disadvantaged children and gives them an experience of flight. Tends to be Kent Gliding Club, because powered flight is quite expensive. So Kent Gliding Club takes some of the money and take up a bunch of kids from, you know, inner city, London or Manchester or wherever, and gives them a bit of a gliding or powered flight lesson. The idea is to show them that, you know, anyone can fly a plane. I grew up in East London. The school I went to was pretty rough. You know, if I can fly a 787 around the world, then, you know, these kids can as well. They've just got to have the drive and ambition to want to do it. And a lot of them don't think they can do it because they think, well, I'm from, you know, Newham or East London, you know, parts of London that I grew up, and they're like, well, I'm from here, I can't do that. That's for, you know, posh people that go to, you know, Oxford and the likes. But no, you can. It's just got to have the will and ambition to do it. When the sim lives at Chris's office, which is near White Waltham Airfield, and every year they have an open day. May still happen this year. It's in September. We'll see if the virus has gone by then. They support London Air Ambulance for various reasons. So we donate the sim to them, and they normally raise, I think it's around 2,000 a year for London Air Ambulance, just for the sim alone, in 15-minute sessions. So, you know, people come along and pay a fair bit of money to sit next to a BA pilot to have a quick go in our sim, a bit of correction factor. And then all the money goes to London Air Ambulance. We take nothing away from it. Barry, our team racing driver, delivers it for nothing. The pilots volunteer, and, you know, it's all done for no costs. So all the money takes goes to London Air Ambulance. Wrong keyboard again. There you go. When we go to the air shows, just in case you've got a corporate day coming up or you're interested, all we need is a plug. So, and this is literally my plug for the sim. See the joke there? No, I don't see anyone laughing. And all we need is a 13 amp plug or one of these Seaform 16 amp plugs, 240 volts. So we've got enough power to run a kettle. We've got enough power to run the sim. So we run all the computers, all the force feedback system, the lights, everything, including the printer, off of a 13 amp plug. I think we come in, last time we measured it, it was just shy of 10 amps. So, you know, we're you know, underneath the 13 amp limit. And the reason we don't really want to go above 10 is because a lot of air shows or wherever we take the sim is normally a 20-meter extension lead of some kind plugged in somewhere, which is then extended off a spur somewhere. So we want to make sure that the volt drop that gets the sim is okay. We do have a uninterruptible power supply, just in case we get brownouts, or in case the power drops off, which happens quite often at air shows. So the UPS unit will keep us going while the computers shut themselves down, or give the pilots 10 minutes to run out and find out what's going on, like you know, the extension leader's caught fire or something, or put more petrol in the generator if we're out in the middle of a muddy field. All the pilots that attend are BA line pilots. We don't have any charlatans, other than Chris turns up every now and again with 8 bars on his wing. And helps us out, but all the pilots are BA captains or first officers that turn up in full uniform. So it's good, certainly at schools and STEM events, and to get out there. And then you might find the right keyword again. If you do want to use a sim, if you definitely want to use it for a corporate event, like it was there in Central London Hotel, you can contact us at bookings@customerfirstteam.org. And one of the team will get back to you, probably Rich will get back to you and organise it. And then we suggest that you go around the garden with the kids. It's pretty good this time of year, making airplane noises, left, right, up, down, bit of fun. And then we'll come along and bring the simulator to your event. If it's a STEM event, then again, reach out to us. What we're trying to do, or what we had this year, was a long list of people that contacted us over the last year or two, with events around the UK, and we're working with our recruitment team. And the plan was that we was going to take the sim to about 20 locations around the UK and doing pilot recruitment, because we were, like literally 3 or 4 weeks ago, about 350 pilots short within the airline, and we was recruiting like it was going out of fashion. Now we're looking at making pilot redundancies for the first time in the history of British Airways. So it's not, the virus has affected kind of the travel and airline industry quite badly, as I'm sure you can appreciate, and we're just wondering when it'll pick up, because everyone's getting used to using Zoom and Teams and GoToMeeting, and whether they'll come back to flying on the planes to go for that important meeting, or whether they'll just make a Zoom call because they're used to doing business that way. Hopefully they'll come back, but otherwise, as I say, if you want to use the sim at your events, then please reach out to us, and when we're allowed back out and Boris has let us out for good behaviour, we will look at the list and see where we can visit and what we can do. We won't have the backing of the recruitment team that will pay for the travel of the sim and the hotels, but we'll see if we can come up with a way of getting the sim around to some events. Certainly, if we can get a corporate client to pay for it, but again, in these climes, I don't think that's going to happen anytime soon. And that is the end of my presentation. So Phil, you can get off your bike if you've jumped back on it. And I'll jump across to see if there's any. How do I stop sharing? Stop. There you go. I'll jump back and just see if there's any questions in the slide.
If I think Kieran's probably still on the call, he can just unmute himself and ask a question.
Yeah.
And then I asked a question, but we can cover that as well.
The VR capabilities. Yes, Prepared 3D does have VR capabilities. And it is something we have looked at quite a lot. And this year, everyone can see you doing that, Chris. This year, over the winter, we did look at using an Oculus for setting up VR. The idea was that we didn't want to set it up for the person that's flying the plane. Various reasons. One, a lot of people become nauseous. We didn't really want people being sick in the sim. It's a bit stinky. Also we wanted the people to get the feel of the size of the cockpit and where the buttons are and the dials and switches, and looking at the visuals, etc. So what we think of doing is having the VR headset. At the back of the sim is a cabin crew jump seat that was taken out of the 767, and we're going to set it up there so someone can put the headset on while they're sitting in a jump seat. It's directly in front of the door, so if they're sick, they'll be sick outside the sim, not inside the sim. And can put the headset on and have a look around. We've tinkered and played with it, but to be really honest, we've been concentrating on getting the sim working and getting it ready for the new season. And it'll be something we'd do, or we were planning to do during the year, this year for putting into sim next winter. Winter is always coming, as we keep saying, and that is the plan. So, what is the WinForms WinWPF code you showing us? It's a WPF app. But as I say, it's been hastily put together over the last 24 hours because I lost the code. It's definitely on GitHub now. I'm certain it's definitely there. I checked, it is there, so I shouldn't lose it again. That'd be my bad. I thought I put it onto GitHub and I was cleaning out my hard drive and I deleted it, and I hadn't. But that's what happens when you're on an aircraft and you're disconnecting the internet and you're sure you've done something but you can't check, and just I've, all my projects are on GitHub. I can delete these files and make space for.
Stop digging.
Right?
Stop digging. Move on quick.
I'll stop digging, Any other questions?
Feel free to unmute yourselves, folks, if you're on the Zoom call. If not,
more importantly, a question back to you guys then. I talked for probably about 50 minutes to an hour there. Do you think it's? I don't think it is, but do you guys think it is? The sort of thing that would be interesting at a conference or more meetups. And if so, would there be areas that need improvement other than me not crashing everything, where you think I could talk more or less on certain parts of the project?
I think we need to get you another computer. So you're running presenting off one and running off a second, and then I think just I mean, I've made a list. I won't share it on the call. There's no point. I've made a list.
You
of
like
small
making
bits of
lists?
feedback. No, just small bits of feedback.
Yeah.
No, thank you so much, Cliff. And if no one's got any questions, obviously clapping on a Zoom call is not great. So what we tend to do is jazz hands. If everyone wants to do jazz hands, you do jazz hands to say thank you very much to Cliff. And what I'll do now is I'll stop the live stream, and then you can crack out the beers.